I'm glad you could join me for this video. This is going to be some examples of solving rational equations. So a rational equation is an equation that has a rational expression, meaning it has fractions with variables. So what you really want to do is avoid the fractions. I don't want to deal with the fractions, and you probably don't want to either. So what you want to do is look at all of your denominators, figure out your least common denominator, and multiply through by the LCD. And that will allow us to divide out or cancel out the denominators and get rid of the fractions, and then solve a simpler equation. So if we look at the first one, notice we have a 1. Remember that you can write anything over 1 as a fraction. So my denominators are 1x and x squared. So if I want to know what the least common denominator is, I need to be able to multiply everything up to that common denominator. In other words, the common denominator couldn't be x because x squared is larger than that. So it has to be at least as big as the biggest number or expression, I guess. So in this case, my LCD is x squared. So I want to multiply through by x squared. So I'm going to multiply both sides of the equation by x squared. Now on the left-hand side, I have two terms, so I have to distribute the x squared to both terms. On the right-hand side, I only have one term. If I'm distributing that x squared, let me show you the way I like to write it. I'm multiplying both sides by x squared, so it's a valid operation. But if I know I'm distributing it, what I can do is just multiply every term by x squared. So I'm distributing the x squared to every piece or every term. The first term, x squared times 1, is going to give me x squared. The second one, I have x squared over x. So that's going to reduce. So I'm going to end up just having 2x. And on the other side, the x squares totally cancel or divide out. So that just leaves me 15. And now I'm going to solve this equation. So this is much easier already without the fractions. Notice I have a quadratic equation. So I'm going to move everything to the same side. So subtract 15 from both sides. And this looks like it will be factorable. I'm going to factor this. So we have x, x. The signs are going to be opposite because the 15 is negative. We need to multiply to get 15 and add to get 2. So 3 plus a negative 5 is negative 2. 3 times negative 5 is negative 15. So those will be the numbers that work. And then to solve, we set each factor equal to 0 and solve. So we will get x equals negative 3 and x equals 5. Now it's very important that you remember that you have restricted values and that your answers cannot be the restricted values. So remember that your restrictions are what make the denominator 0. So in this case, you have an x and you have an x squared. Either way, if you plug in a 0, that's going to make your denominator 0. So your restrictions, and really I should just say restriction because there's only one in this case. Your restriction is that x cannot be 0. You got negative 3 and 5. So both of these answers are valid. So they're good. Now sometimes you might get an answer once you solve the equation that is the same as your restricted value. Well, in that case, you have to eliminate that. It's not a valid solution if it's restricted. So keep in mind, you need to check your answers in this when solving these kind of equations. So number 2 is next. This one's a little bit more complicated. So in order to find the least common denominator, you want to make sure that all of your denominators are fully factored. And so the first denominator is x plus 1. That's one factor. The second denominator is x minus 1. That's a factor. But the third denominator is x squared minus 1. And this can be rewritten as x plus 1, x minus 1. So you want to make sure you fully factor all of your denominators, and that's going to make your life much easier. When you're trying to define your LCD is always the product of each unique factor raised to any exponent that you see in the denominator. So each unique factor has to be included. That means every factor that is different needs to be included in the LCD. So the first denominator is x plus 1. Since that's the first denominator I see, I have to include it. The next denominator's factor is x minus 1. Well, x minus 1 is different than x plus 1, so I have to include x minus 1. If I look in the third denominator, I see a factor of x minus 1. Well, that's already been included, so I'm not going to write it again. I also see a factor of x minus 1. That's already been written down in my LCD, so I'm not going to include it again. So I've included all the different factors, so my LCD is x plus 1 times x minus 1. So what I'm going to do now is distribute that. I'm going to multiply each term by the LCD. So each term gets multiplied by x plus 1, x minus 1. I should be able to cross out all of my denominators. If I can't, that means I did not pick the LCD. So x plus 1's cancel out in the first fraction, and it will leave a 2 times an x minus 1. In the second fraction, the x minus 1's cancel out, and that will leave plus 1 times x plus 1. In the last fraction, x plus 1's cancel and the x minus 1's cancel. And that just leaves me with a 1. All my denominators canceled out with my LCD, so that was good. Now I just solve the resulting equation. So distribute the 2, and that will give me 2x minus 2. Distribute the 1, that will give me x plus 1 equals 1. Combine my like terms, so I've got 2x and an x, and a negative 2 and a 1. So 2x plus x is 3x. Negative 2 plus 1 is negative 1. Add 1 to both sides. So I get 3x equals 2. Divide by 3. X equals 2/3. You want to make sure this isn't one of your restricted values. So your restrictions are anything that would make the denominator 0. In other words, each factor has to be set equal to 0. The easiest thing to do is look at your least common denominator. So your least common denominator was x plus 1, x minus 1. What you can do is set that equal to 0 and solve, and then that will give you your restrictions. So that means x cannot be negative 1 and x cannot be 1. The answer that I got was 2/3. So we're good to box that in and claim that as a solution. All right, let's look at number 3. So number 3, the first thing you want to do, so let's just write down steps. Maybe that will help somebody. So the first thing is factor all denominators. So the first fraction has a denominator that has an x squared. So that's kind of a red flag that you can probably factor it. So x minus 5 minus 2, because negative 5 times negative 2 gives you that positive 10. And negative 5 plus negative 2 gives you the negative 7 in the middle. Notice that the factors that I just got from factoring match the denominators of the other two fractions. That usually happens because then it makes your life easier when you're trying to find the LCD. It's it's not going to always happen, but in the problems that you will see, it's more than likely going to be the case. So first step, factor all denominators. The second step is to determine the LCD. Okay, so I'm going to include each unique factor that appears. So LCD. The first factor I see is x minus 5. The next factor I see is x minus 2. The next factor in the next fraction is x minus 5. I've already included that. And then I see x minus 2. I've already included that. So there's my LCD. The third step is distribute the LCD to all terms. So every term gets the entire LCD. So I'm going to multiply this numerator by x minus 5, x minus 2. This one by x minus 5, x minus 2. And this one by x minus 5, x minus 2. So after you do that, remember that you're not multiplying through by that. You're then going to cancel out common factors. The whole point of multiplying is to cancel out your denominators. So another reminder, all denominators should cancel out. If they don't, then you did something wrong. So in our first fraction, we have the x minus 5s, those cancel. And we also have the x minus 2s, those cancel. So all we're going to have left is our original numerator, which is x plus 13. In the second fraction, we have the x minus 5s that cancel out. And so we're going to have 6 times the x minus 2. And then in our third fraction, we've got the x minus 2s that cancel out. So we have a minus 4 times x minus 5. Okay, so now we've done the third step. Now we're just going to solve the resulting equation. So sometimes it might be a linear equation. Sometimes it might be a quadratic equation. So you just solve whatever you get. So we need to distribute the 6 and the negative 4. So I'm going to bring down x plus 13. Distributing the 6 will get me 6x minus 12. Distributing the negative 4 will get me negative 4x plus 20. Combine like terms on the right. So 6x minus 4x is 2x. Negative 12 plus 20 is 8. This is a linear equation, meaning I don't have an x to a power, it's just x to the first. So I'm just going to move all my x's to the left and my constants to the right. So subtract 2x from both sides, subtract 13 from both sides. So that'll leave me negative x equals negative 5. Divide both sides by the negative, negative 1. That will give me x equals 5. Don't forget to check your restrictions. So that is the last step. Check your restrictions. Restrictions come from setting your denominators. The easiest way here is setting your LCD equal to 0 and solving. So this means x minus 5 equals 0, so x cannot be 5. And x minus 2 is 0, so x cannot be 2. Notice your restriction here, x cannot be 5. But what did we just say was the answer? We got 5. This is a contradiction. So this is not a valid solution because it's on our list of restrictions. So if our solution is actually a restricted value, then we have to say that there is no solution. So if you forget the last step, which is to check your restrictions, you're going to miss a problem or two, or however many your teacher decides to put on your homework and or quiz or test. So don't forget to check your restricted values. This is very important. All right, I'm going to erase all of that so I have room for number 4. Okay, so let's see. First step, factor all denominators. There are no exponents on my variables here, so I was going to say there's nothing to factor, but that's not actually right. The last one I could factor out a common factor. So I could factor out a 3 because both terms have a 3 in common, and that would give me 3 times x plus 1. So that actually is helpful because the x plus 1 matches the x plus 1 from the first fraction. Now I've got them fully factored. So the next step is to determine my LCD. So the first thing I see is x plus 1. The next factor I see is 2. The next factor I see is 3. Those are all different. I'm including them all. And then the next factor I see is x plus 1. And I've already written x plus 1, so I'm not going to write it again. This is all multiplying. So 2 times 3 is 6. So I could rewrite this as 6 times x plus 1. And it might be easier to think of it in that way. But you can just leave it as x plus 1 times 2 times 3 as well, because guess what? You're going to end up crossing those out. So either one is fine. I would probably lean toward using this. All right, the next step is to distribute your LCD to every term. We've got 3 terms, 3 fractions in this case. So we're going to multiply each numerator by the entire LCD. So 6 times x plus 1. I didn't mean to make it look like a fraction bar there. Okay, so 6, and x plus 1. All right, so let's see what cancels out now. In the first fraction, the x plus 1's cancel, and I'll have 4 times 6. In the second fraction, the 2 cancels with the 6, so 2 goes into 6 3 times. So I have a minus 3 times 3 times x plus 1. So just to show, I have a minus here, a 3, and a 3, and an x plus 1. Okay, equals, in the last fraction, the x plus 1's cancel, and the 3 will go into 6 2 times. So 3 is gone, 6 becomes a 2. So what I have left there is 4 times 2. And now I just want to solve this resulting equation. So I can do the multiplication. 4 times 6 is 24, minus 3 times 3 is 9, equals 8. I'm going to distribute my 9, my negative 9. So 24 minus 9x minus 9 is equal to 8. Combine like terms on the left, so 24 minus 9, so I'll have negative 9x plus 15 is equal to 8. This is a linear equation, so I'm trying to get everything away from the x. So subtract 15 from both sides. I get negative 9x equals negative 7. Divide by negative 9. So x equals, the 2 negatives cancel out, so x equals 7/9. Don't forget to check your restrictions. So restrictions. Set your denominator, in other words, your least common denominator, equal to 0 and solve. So 6 equals 0. Well, that doesn't lead to a solution because there's no variable. X plus 1 equals 0, so x cannot be negative 1. That's my restriction, negative 1. That's not the answer that I got. So the answer that I got of 7/9 is a valid solution. All right, last one. If you haven't done so yet, you may want to try to do this one on your own, and then you can come back and check your answer and watch the explanation if needed. So here is our fractions. First thing we want to do is make sure all denominators are factored, and they are. The last one is an x, so that's like x over 1. We don't need to do any factoring, so the next step is to determine our LCD. There's only one factor in the denominator. That factor is x minus 8, so that's going to be our LCD. So at this point, we're just going to multiply through by the x minus 8. So distribute that to each term. X minus 8's cancel out in the first fraction and the second fraction. So all we're going to have left is 8x minus 48 plus 3x is equal to x times x minus 8. So the only place the x minus 8 kind of sticks around is the right-hand side. It cancels out on the left-hand side. So we're going to distribute the x on the right-hand side. We're going to combine like terms on the left-hand side. So 8x plus 3x is 11x minus 48 is equal to x squared minus 8x. Notice this one is a quadratic equation because I have that x squared. That means I want to get everything on the same side of the equal sign and set it equal to 0 so that I can factor or use the quadratic formula. Since x squared is positive where it is, I'm going to leave it there and move everything to it. So minus 11x plus 48. So I have x squared minus 19x plus 48 is equal to 0. Now I have to figure out what multiplies to get 48 and adds to get 19, if it's factorable. I'm hoping it is, but if it's not, we'll just do the quadratic formula. So let's see. What multiplies to get 48? So we have 1 and 48, 2 and 24. I think 3 and 16, and that looks like it's going to work. If I use a negative 3 and a negative 16, that will add to get 19, negative 19. And if I multiply negative 3 times negative 16, it will give me a positive 48. So that should work. So minus 16 minus 3. Okay, so now x minus 16 equals 0. So x equals 16. And x minus 3 equals 0. So x equals 3. Last step, check your restrictions. So take your LCD, set it equal to 0. So my LCD is x minus 8. If I set that equal to 0 and solve, I will see that x cannot be 8. That's neither of the answers that I got below, so both of those are valid solutions.